Hello, we are in section 1.8 and this is an extension to what you did in class today. We're going to talk about how to write inequalities using interval notation. Now I'm going to be honest, I've never seen this before. This is completely new to me as well. So when I started looking through your book, I thought, wow, I've never done this either. So I first had to learn it. So it's very easy to learn once you understand it, but it can be a little confusing when you start this process. So the first thing I want you to do is look at student page 74. So go to student page 74 in the gray box that starts talking about interval notation. So let's look at an example. I'm going to write an example down. Before we actually explain the box, I'm just going to write an example. Here's the number line I just drew. Let's put a graph in here. So I've shaded an inequality that has a closed circle on 2 and it shades to the right. So if you wrote this as an inequality, you would write it as x is greater than or equal to 2 because it's a closed circle, which means that 2 could be a solution to the inequality. Now in interval notation, it's going to look like this. And it means the exact same thing. But I want you to understand first, let's just look at this and think what these things mean. So let's start with the bracket. The bracket is going to tell you whether or not you have an open or closed circle. If you have a bracket, that means your circle is going to be closed. If you had a parenthesis on this side, it would be an open circle. So once again, bracket means you have a closed circle. Parenthesis means you have an open circle. So if you have a parenthesis, that means you either have a less than or a greater than symbol. If you have a bracket, you're going to have a less than or equal to symbol or greater than or equal to symbol. Now the infinity is the way you shade. So if your infinity is on the right side, that means your graph is going to go to the positive side of infinity. So positive infinity is to the right. Positive infinity is to the right. Positive infinity is to the right. And then you have a parenthesis. So whenever you shade on either side, you're always going to have a parenthesis. So whatever way it goes, it's just going to be a parenthesis. So let's just try an example. So in this problem, you don't have to write this down. Just watch. We have negative infinity comma negative 3. So we have a number line. We know we're going to have to put a negative 3 here, so I'm just going to draw negative 1, negative 2, negative 3. Now, because we have a parenthesis, that means negative 3 is not a solution. Therefore, it has to be an open circle. And because we're going negative infinity, that means we shade to the left because your numbers get smaller. So it never ends to the left. So our numbers get smaller and it never ends. So you're going to actually shade to the left. So we would have an open circle on 3 and shade to the left. Let's try another one. In this problem, we have 1, 5, with 1 being the parenthesis and 5 being the bracket. So that means because I do not have infinity or negative infinity, you are not going to shade to the right or left without end. So we know we have to have at least a 1 and a 5 here. So I'm going to count to 5. 2, 3, 4, 5. 1 has a parenthesis. That means it's not a solution. I put an open circle. 5 has a closed dot because it has a bracket. And then we shade in between. But your line, your shaded region, does not go to infinity on the positive side or negative infinity on the left. So if you look at your little chart, it explains everything I just told you. So if you want to look at where it says parentheses, brackets, and infinity, it tells you how to distinguish between which ones you use. It also gives a few examples, 2 of which I've done for you in the gray section. So let's go to the got it problem on problem A. The question asks, what is the graph of negative 2, 7? How would you write negative 2, 7 as an inequality? So let's first figure out what our graph would look like. So we have -2 all the way to 7. We would know that since -2 is not a solution because of the parenthesis, I would put an open circle on -2. 7 will be a closed circle since we have a bracket. And then we would shade everything in between. So any region that goes from -2, without including -2, all the way to 7 would be an answer. Now we also have to write this as an inequality. So this will be a compound inequality. Now remember, if you shade inward, that's an and problem because it's the solution to two separate inequalities. All you have to do is this. -2 is our lowest point, 7 is our highest. Because -2 is not included, it's just a less than. Because 7 is included, it's less than or equal to. And the value of x goes in the middle. So what this says is that x has to be greater than -2 because we're shading to the right, and that's important. And tells us we're shading inward because it's the region that overlaps, and x has to be less than or equal to +7 because we have a closed dot on 7 shaded to the left, and the shaded region represents the compound inequality of the region that makes x is greater than -2 true and x is less than or equal to 7. So this is all I need. You don't have to write the second part, but this is the answer that I want. -2 is less than x, which is less than or equal to 7. So why did you learn this? That's always a question that students ask. You learn this because interval notation is just another way to write an answer, and it's actually more compact. So it actually could take less time to write interval notation than an actual inequality, which would be fine for you to do. But you can use interval notation to describe an interval on the number line.